Good day, everyone. Today we are going to complete the chapter Solutions of Chemistry, class 12, and we have come to the last part, that is osmotic pressure of solution. Before we study osmotic pressure, we'll understand what is osmosis. Osmosis is the phenomenon of the flow of solvent molecules through a semi permeable membrane from pure solvent to the solution. It is very important to note that the transport will always happen. The transfer will happen from a pure solvent to the solution. So, what is a semi permeable membrane? Semi permeable membrane allows the solvent molecules like water to pass through their holes. However, it will stop the passage for bigger molecules of solute like salt. It has very small holes so that the transfer will only happen from the pure solvent to the solution. So, if the semi permeable membrane is placed in between a pure solvent and solution, then the transfer will only happen in this particular way. And these membranes can be natural, such as the animal's bladders or parchment, or can be synthetic, such as cellophane. So these membranes will appear to be continuous sheets or films, but they will have some submicroscopic holes or pores in them which allow the transfer of the molecules. So if the osmosis can take place between the solutions of different concentrations, then the solvent molecules will move from a solution of low solute concentration to a solution of high solute concentration. So this flow is continuous until an equilibrium is attained. So we have to note that the solvent particles will move from a low solute concentration to a high solute concentration only. We will talk about some of the examples of osmosis. So it is used in the prevention of meat by salting of and of fruits by adding the sugar, protects against bacterial actions. So through the process of osmosis, a bacterium on the salted meat or sugared fruits loses water, shrivels, and will not be able to grow. And next, the water movement from soil to the plant roots and subsequently into the inner portions of the plant is partly due to osmosis. And osmosis is also used in making pickles, because a raw mango placed in concentrated salt solution loses water via osmosis, and the flowers will revive when placed in fresh water, and through osmosis the blood cell collapse due to the water of the loss of water when placed in water containing more than 0.9% of salt solution. So all of these are the examples of osmosis. Now we will study about osmotic pressure, which is represented with this symbol. So the osmotic pressure of a solution is the excess pressure that must be applied to the solution side of the membrane to prevent osmosis. So we will assume this kind of a setup, and this is the solution and this is the solvent. So according to the osmotic pressure, it states that we will apply an external pressure on the solution side to prevent the osmosis to occur. So our main motto is to stop the passage of the solvent molecules through the semi permeable membrane as it will we apply the external pressure. So this particular osmotic pressure is a colligative property as it will depend upon the number of solute molecules present in the solution and will not depend on their nature. So now we will study how to find out the molar mass of the solute. So the osmotic pressure is directly proportional to the concentration of the solution at a given provided heat. So your concentration is taken to be molarity. And for dilute solutions, we remove the proportionality symbol and we write the constants, that is R and temperature. So here R represents the gas constant and N2, that is the number of moles, is weight of the solute by molar mass of the solute. And C here is the molarity, so the number of moles of the solute by the volume of solution. So by substituting the values, we can find the molar mass of the solute with this following equation. And the osmotic pressure is measured by this particular method. A question is provided for you to solve. So what is the advantage of osmotic pressure? So osmotic pressure method has the advantage over other methods as the pressure measurement is around the room temperature and the molarity of a solution is used instead of molality. And as compared to other colligative properties, its magnitude is large even for very dilute solutions. And the technique of osmotic pressure for identifying the molar mass is practically useful for biomolecules as they are generally not stable at high temperatures and polymers have poor solubility. Now we will study about the different types of solutions. So the first type is the isotonic solutions. So the two solutions having same osmotic pressure at a given amount of heat are called the isotonic solutions. There is no osmosis between these two solutions as they have the same molar concentration. One of the example is the osmotic pressure associated with the fluid inside the blood cell is equivalent to that of 0.9% of mass by volume of sodium chloride, which is called the normal saline solution, and it is safe to inject intravenously. So here in this, the solvent particles will move in both the backward and forward ways and the cell size will be normal in isotonic solutions. Moving to hypertonic solutions. So a solution having more osmotic pressure than the other solution. So one such example is if we place the cells in a solution containing more 0.9% mass by volume of sodium chloride, then the water will flow out of the cells and they could shrink. This is called plasmolysis. In this solution, the water will move out of the cell and so the cell will shrink in hypertonic solutions. In hypotonic solution is that it is a solution having less osmotic pressure than the other solution. For example, if the salt concentration is less than 0.9% sodium chloride, then the water will flow into the cells. So in the hypotonic solutions, the water will flow into the cells and so the cell swells up. Next we'll speak about reverse osmosis. So the osmosis can be reversed if the pressure larger than the osmotic pressure is applied to the solution side. The pure solvent will flow out of the solution through semi-permeable membrane. We'll further speak about this reverse osmosis while we are reading the ncert. Moving to the abnormal molar mass. So we've already studied that the colligative properties will help us to calculate the molar mass of solutes. But the molar masses that can either be lower or higher than the expected or normal values. So the cases of association and the reverse process of compounds is the reason for this abnormal molar mass. So first we'll speak about association of molecules. So association of molecules leads to the reduce in the number of particles in the solution, resulting in reduce in the value of the colligative properties. So colligative properties are inversely related to the molar mass of a compound. Therefore, higher the value of the obtained for the molar mass than the normal values. For example, ethanoic acid in benzene undergoes dimerization and it shows the molar mass of 120 instead of 60. This is because of the hydrogen bonding which it associates. Moving to the next part. This association of molecules leads to the increase in the number of particles in the solution, therefore increase in the value of colligative properties. Due to this, lower values obtained for the molar mass than the normal values. So, if we take potassium chloride and water, then it will break up into K plus and Cl minus, and the molar mass is observed to be 37.25 instead of normal molar mass which is 74.5. So the Van 't Hoff has come up with a factor to understand this abnormality in molar masses. So then they have come up with the Van 't Hoff factor, which is represented by small I. So in 1880, Van 't Hoff has introduced a factor I known as Van 't Hoff factor to account for the extent of the associations which are happening. So it is defined as the ratio of the experimental value of the colligative properties to the calculated value of the colligative properties. So these are the following formulas, and this is a very important equation because the colligative properties are inversely proportional to the molar mass. In association, the I value will be smaller than 1, and in the other process the I value will be greater than 1. So with the introduction of the Van 't Hoff factors, they have been modified forms of colligative properties where we add the Van 't Hoff factors in our equations. So these are the revised or the modified colligative properties equations. Let us solve a question. The question is that we have to find out the amount of CaCl2 which is mixed up in 2.5 liters of water such that its osmotic pressure is given. So we know the formula of osmotic pressure and they have already provided us with the volume and the value of temperature, and we have to find the number of moles first, and then we can multiply the molar mass with the number of moles to obtain the amount of CaCl2, which is using Van 't Hoff factor we can identify the degrees of association and the degree of this association as well. So now we will solve the questions. So the question is that an aqueous solution of 2% non-volatile solute exerts a pressure of 1.004 bar at a normal boiling point of solvent. What is the molar mass of the solute? So the answer is, we already know the vapor pressure of the pure solvent and the vapor pressure of solution, and the mass of the solute is taken to be 2 grams. Mass of the solvent is 98 grams because 2%. So we have 2 grams of solute and 98 grams of solvent in the total mass of solution to be 100 grams, and using the formula we can find out the answer to be 41.35 gram per mole. Moving to the next question, that is the boiling point of water at 750 ml of Hg is given. So how much sucrose is needed to be added to 500 grams of water such that it boils at 100 degrees Celsius? So here the mass of water is provided for us, which will convert it into kg, and the elevation and the boiling point we have found out, and the constant value is given. So The molar mass of sucrose is we have to calculate and then put all the values in the equation, and then we'll get the answer to be 121.7 grams. Now we have completed the theory part and we will read the ncert. So in the ncert, the osmosis and osmotic pressure and the diagram is given, and the semi-permeable membrane and how the osmosis will take place, and there is the external pressure so that we can stop the process of osmosis, and the osmotic pressure is discussed, and these are the formulas. And then the solutions, that is isotonic, hypertonic and hypotonic, and the examples are given. And then the reverse osmosis and water purification. So the diagram will explain the whole thing. So here, when a pressure higher than the osmotic pressure of the sea is applied, then the pure water passes through the semi-permeable membrane, leaving the salt ions and other impurities behind. So the pressure required for the reverse osmosis is quite high, and variety of polymer membrane is available for the purpose, and most commonly used or placed over a suitable support semi-permeable membrane is that of cellulose acetate. And this method of purification is adapted for the regions where fresh water is scarcely available. And then questions are provided, an abnormal molar mass and the equations, and the modified colligative properties and their formulas, and the example questions. And the summary. You give a quick reading to the summary because it is also very important and some key points will be there. So with this, we have completed chapter 1, solutions of class 12 chemistry, and further we are going to start the next chapters. Thank you so much for watching. Stay tuned for more videos.